and this video is estimated time of arrival in our navigation video series. Navigation, the art and science of directing the movements of a vessel safely, confidently, and efficiently from one location to another. All right, this video is going to cover estimated time of arrival. And when we're done with this video, we want to be able to state how estimated time of arrival is used in navigation. We want to be able to plot and properly label the latitude and longitude for beginning and ending points. Demonstrate how to connect the points and draw a line with the parallel ruler. Demonstrate using the dividers to measure the length of the track line in nautical miles. Demonstrate how to use time, speed, and distance formula to calculate time it will take the vessel to travel. And demonstrate how to add the travel time to the departure time to calculate the ETA. All right, so estimated time of arrival, what is it? It's basically the estimated time a vessel will arrive at a given location at a given speed. So as an example, we have a problem here. At 2020, you're in position 36 degrees, 50.02 north, 75 degrees, 56.8 west. What is your ETA, or estimated time of arrival, to position 36 degrees, 54.28 minutes north, 75 degrees, 42.75 minutes west, if we're making 11.9 knots? All right, so first thing I want to do is plot the starting position, latitude, and longitude. So what's our starting position? 36 degrees, 50.02 minutes north, 75 degrees, 56.8 minutes west. So if you look to this picture here, just to the right of our question there, you see I have an arrow pointing just above 36 degrees, 50 minutes. So this is 36 degrees where my cursor's at, and this is the 50-minute line or mark. So this whole line right here is 36 degrees, 50 minutes north. And look at our position, it's 0.02. So each of these marks here are tenths of a nautical mile or tenths of a minute. So 0.2 is a hundredths. So we're basically looking way down here somewhere, like just off the top of this line. So on this scale chart, it's impossible really to navigate or to get your mark that close. So what we're going to do is, just for the purposes of this problem, we're going to use 36 degrees, 50 minutes. So we're going to use this line, here I just highlighted in red, as our latitude mark. And then we go over here for longitude. You can see I have 76 degrees here, and there's a line that goes all the way up the chart from south down here north. It runs all the way straight up and down. I'm going to use that as my reference line. And then I marked, so this would be 76 degrees. This would be 75 degrees, 59 minutes. This would be 58, 57. So we're at 56.8. So here's the 56 line. Here's 56.5, 6, 7, 8. Right there where my pencil's at, or the pencil lead on my dividers. And you can see it's right on top of the safe water marker entrance buoy to Rudy Inlet. So that's the starting position. Now we have to plot our ending position. So ending position, again, it's a latitude and longitude that we're given, and our ending position is 36 degrees, 54.28 minutes north, 75 degrees, 42.75 minutes west. So I have my dividers. I have the pointy end at 36 degrees 50, because if you remember from that last slide, and you can see the line here just under the dividers, that line goes all the way across, so it's a great reference line. And then I'm going to measure up. Here's 51, 52, 53, 54, and then 1, 2, and I'm not quite at 3 because it's 0.28. So I'm not quite at 3, but I'm just below it. And then my longitude down here is 75 degrees, 42.75 minutes west. So at 75 degrees, 40 minutes, which you can see the line here, the 40 minute line, that goes all the way up the chart. So I'm going to use that as my reference. I go 41, 42, 42.5, decimal 6, decimal 7, decimal 8. So I'm going to go right in the middle of those two, decimal 7.5. I'm going to mark this position. And that position, if you look up here, turns out to be Chesapeake Light. So for this problem, I've got the RI safe water mark outside of Rudy Inlet that we marked earlier in Chesapeake Light. So my next step, I'm going to take my parallel ruler and line up the top edge with the exact center here of the RI, and then the bottom of the exclamation point, which is explained in our ATON videos, with Chesapeake Light. All right, so I've got those two. Go back real quick, and I'm going to draw a line between the two. And the reason I'm drawing a line is because when I measure that distance, I want to stay on the same plane. I don't want to get crooked, basically, and exaggerate the distance or mismeasure. All right, so when I look at the line there between those two marks or positions, I can tell it's going to be over 5 nautical miles. And whenever I'm over 5 nautical miles for distance, I just take my dividers and I measure out 5 nautical miles on the latitude scale. So remember, every minute here of latitude equals 1 nautical mile. Only on latitude. You can't do that with longitude. Only on latitude. So I mark out that 5 nautical miles. And then I'm going to start here at the RI buoy, which is my starting point. Mark 5 nautical miles. And then go to my 5 nautical mile mark. Mark another 5 nautical miles. And then go to that second 5 nautical mile mark. And I don't have 5 nautical miles till I get to Chesapeake Light. So I'm going to squeeze my dividers in until they line up perfectly with my second 5 nautical mile mark and my finishing position, which is Chesapeake Light. When I do that, it gives me 11.9 nautical miles. So quick review. We plotted our position, 3650.02, 75 degrees, 56.8 west. We plotted our second position here, and then we measured the distance between the two, and our distance was 11.9 nautical miles. Now, we're going to compute the time it's going to take us to travel that 11.9 nautical miles at 11.9 knots. So we're trying to get the time here. So how do we get time? Time equals distance times 60 divided by speed. So in this problem, our distance is 11.9 times 60 divided by 11.9, and we get 714 divided by 11.9, which gives us a time of 60 minutes. And just a quick check, remember, a knot is a nautical mile per hour. So if I'm doing 11.9 knots, I'm going to do 11.9 nautical miles in 1 hour. It's just like saying if I did 11.9 miles per hour in my car, after 1 hour, I would have gone 11.9 miles. All right, so the next thing I have to do is add this 60 minutes to my starting time. My starting time was 2020. So if you look over here, my cursor's at, I take 2020 plus 60. So there's no hours on that side. It's only 60 minutes. Put those over top of each other. I draw a line down the middle of them to keep my minutes separate from my hours. So 20 plus 60 equals 80. And I bring down the 20 here. So I've got my time is 2080, which isn't a time. So I need to, I've got more than 60, so I need to subtract 60 from my minute side. And that leaves me with 20 on my minute side, But that 60 I subtracted, I need to make sure I bring it over to my hour side, because remember 60 minutes is 1 hour. So I end up with 21:20 as my estimated time of arrival. All right, this concludes our estimated time of arrival video for our navigation video series. Please check our YouTube channel for other videos